Hello everyone. Today we're going to look at the fourth point from the Appy Flight logbook, which is about piloting. This topic is a bit lengthy and covers several areas. We'll discuss the takeoff, flight, and landing processes, and what to do if the radio communication fails. We'll also talk about relative speeds, ground speeds, hands-up speed range, and the minimum sync rate, as well as trajectory, wind drift, and how to use two reference points. Regarding the takeoff process, you can find the theory in the logbook on page 50. The phases of takeoff are divided into 5. Sometimes they're fewer, but the flight book divides them into 5. The first is inflation. The second is the control stage. When the wing is inflated, you should release the risers and break the wing. At that moment, we reach the third stage, which lasts less than a second, where you decide whether to take off or not. If there's a problem, you abort the takeoff. If everything's perfect, you decide to take off and accelerate. The fourth stage is acceleration, where you must run decisively. Gradually raise your hands if you've braked during the control stage. Finally, the fifth stage is takeoff and flying away. Remain upright, avoid sitting too early, and steer clear of the mountain without letting go of the brakes. Regarding landing, the logbook covers theory as well, with details on page 49. There are 3 basic landing techniques. The simplest is making S-turns to lose altitude, always facing into the wind before landing. This is how most students make their first approaches. For more advanced students, on page 51, there's a diagram of the U-shaped landing approach, which is often used in crowded landing zones. Some key points for landing are to stand up early, gain speed, and raise your hands. The faster you go, the more effective the flare will be. You can make slight adjustments to your path, but in the final approach at low altitude, sharp turns are not advisable as they increase descent speed and could cause injury. If you need to avoid an obstacle, make turns using your body and a bit of brake, and just before touchdown, about 1 meter or less from the ground, perform the flare. This is the full brake of the wing to create a dynamic stop, allowing you to land softly. During the flight, depending on your stage of learning, your instructor will give you directions by radio. The basic instructions will be directional, telling you to turn right or left, using the brake and your body. The instructor might avoid saying left or right to prevent confusion, instead using visual references like turn toward the mountain, turn to the sea, turn to the tree, or turn to the house, avoiding any confusion with left or right. Now, what if the radio fails? The first thing is to stay calm. If it's one of your first flights, you're likely in a training field, a dune, or a school hill where there are no major obstacles. Stay calm and head into the wind, which will be the same direction you took off. If there are wind indicators, like windsocks, align yourself to fly against the wind and aim for an obstacle-free area. If you do that, nothing bad will happen. If you're flying in a more advanced area and it's your 5th, 10th, or even 20th flight, and you lose radio contact, your instructor has probably already explained how to approach landing. Stay calm, trust that you can land on your own. Follow the approach you were taught, face into the wind, stand up early, and perform the best flare possible. Now, about airspeeds and ground speeds. A paraglider always has a relative speed, known as airspeed. What does that mean? Hands up, the paraglider will fly according to its specifications. For example, 38 kilometers per hour, whether you're flying into the wind, with a tailwind, or with crosswinds. That's its airspeed. What changes is the ground speed. For instance, with hands up at 38 kilometers per hour and a 10 kilometers per hour headwind, your ground speed will be about 28 kilometers per hour. Likewise, if you have a tailwind, the wind speed will be added to your airspeed. If your airspeed is 38 kilometers per hour and the tailwind is 10 kilometers per hour, you'll fly at 48 kilometers per hour over the ground. This is crucial to understand, especially when talking about minimum speed. We know the minimum speed is the threshold below which our paraglider will stall. This is typically around 20 kilometers per hour and is an airspeed, not ground speed. So, if you have a 20 kilometers per hour tailwind and brake 100%, your ground speed may be 40 kilometers per hour, but your airspeed will be 20 kilometers per hour or less, meaning you could stall even though your ground speed is 40 kilometers per hour. Some students confuse this concept, thinking that because they're flying fast, they can brake a lot, but they're unaware that their paraglider might be below or near its minimum airspeed. There are two speeds that often get confused: the best glide speed and the minimum sink rate. The best glide speed is usually achieved with hands up. This is the trim speed, where the paraglider is designed to optimize its glide. The minimum sink rate is achieved by lightly braking both brakes, slowing the wings slightly. What's the difference? Best glide is for covering the most distance, while minimum sink is for maximizing flight time. You'll want to use minimum sink when flying in a smooth thermal or light lift, slowing the wings slightly to stay in the lift zone longer. Best glide is useful when you want to move from point A to point B. Finally, let's talk about trajectory and wind drift. With zero wind, your flight path will head directly where you point it, but we usually fly with some wind, which pushes us in the wind's direction. If you're flying toward a specific point and have crosswind, the wind will push you off course. If you don't compensate for wind drift, you'll constantly have to adjust your direction, which is inefficient and can cause the wing to oscillate. To reach your destination, compensate for the wind by leaning your body and applying a bit of brake on the opposite side of the wind. This way, you'll fly straight toward your target even though you're angled slightly into the wind. A tip to maintain your course is to use not just one visual reference point, but two. Focus on a specific point and what's behind it. If they stay aligned, you're on course. If they don't, you're drifting, and you need to compensate more. That's it for the piloting section of the API 1 course theory. Remember, I've left key questions for reviewing your knowledge in the description box, along with related videos. Thanks for watching, and don't forget to subscribe to my channel and give it a like. See you in the next video.